Hi everyone. Today we'll talk about typecasting. Swift supports the typecasting between the classes that are related. Either you are casting from a parent class to a child class, which is called downcasting, or casting from a child class to a parent class, which is called upcasting. For example, we have a class media, and then we have a song which is derived from media, and movie also derived from media. And then we create a S1, which is a song fireproof, and then we create a M1, which is a media, and assign S1 to M1. What we are doing here is we are casting S1 from a song to a media and then assign to M1. This is upcasting, and upcasting can be implicit. Now M1 is a media, and we create S2, which is another song, and we are assigning M1 to S2. This is downcasting, and downcasting must be explicit. We have to use the as keyword to cast M1 from a media to a song and then assign to S2. And the downcasting must be correct. In other words, M1 must be a song under the hood. Although in the eye of the compiler, M1 is a media, we know really M1 is a song. That's why it can be safely casted into a song. But if we want to cast M1 to a movie, then it will be a runtime error because M1 is not a movie. This casting is illegitimate. Now let's look at another example. We have an array A which contains a song of Fireproof, a movie of Shrek, and a media of King Kong. As we talked about in previous video, the type of A will be inferred to be an array of media. So A0, although we know it is a song, in the eyes of the compiler, it will be considered a media. If we assign A0 to a variable of a song, we have to downcast A0 to a song first. And we know A1 and A2 are not songs, so if we are casting A1 to a song or A2 to a song, it will be a runtime error. This poses a risk. What if I forgot what the type of A1 is, and we did the illegal downcasting accidentally? My program will crash. How can I avoid such thing from happening? One way to do it is you can check if A1 is a song and then do the downcasting of A1 to a song. This will be safe. Alternatively, you can do optional casting. Let M2 equal to A1 as song. So this kind of casting will return nil if A1 turns out not to be a song, and return an option of song if A1 is indeed a song. So M2 is an optional of song. You can also do optional binding if let M4 equal to A1 as song, and then do something with M4, and M4 is a song. When you do the casting back and forth, you are not modifying anything of the object. You are merely changing the compiler's view of the object. Nothing inside the object is changed. One thing to note is the built-in data types don't support casting. For example, let x equal to 45. X will be an integer. And then we do let y equal to x as double. We are casting x from an integer to a double. This may sound like a reasonable casting, but it won't work because both integer and a double are structures, and structures doesn't support inheritance. Therefore, they cannot be the relationship of subclass and superclass. That's why you cannot cast between them. Remember, downcast and upcast can only happen between classes. They cannot happen between structures or between enums. Now let's talk about a special kind of type called any object. And any object can be thought of as the superclass of any other classes. In other words, any other object can be upcasted to this any object and then downcasted back. For example, here we have an array A1. A1 is an array of any object. And since it's an array of any object, we can put any kind of object into the array. It can has a media, it can has a son, it can has a dog. So any kind of class can be put into A1. And then we can iterate through the A1 by using for x in A1. If x is a dog, we print out a dog is found. So as you see, any object can be very handy when you want to have an array that contains different kind of object in it. Another example, we have a A2, which is also an array of any object, and A2 has a media and has a son. And then we can cast A2 into an array of media. So the entire array of any object is casted into an array of media. This will work because A2 contains only either media or the subclass of media. Now let's talk about a very similar kind of type called any. Any is similar to any object, except that any is even more versatile. Basically, any kind of data can be casted into the type of any, regardless of whether it is a class or a structure or an enum or even a closure. Any kind of data. For example, here we have A3, which is an array of any. And A3 can have an integer, can have a double, can have a string, can have an object of dog, can have a tuple, and can even have an optional. So any kind of data can be stored in the array of any. And to iterate through the array, we can use for x in A3, switch x, and based on the value of x, doing something specific to that data. One thing to note is that A3 has an integer of 2 and a double of 2. Usually you cannot differentiate between an integer of 2 and a double of 2, but in Swift you can. You can do case 2 as integer, do something, and then case 2 as double, and do something else. So the richness of the type system makes this kind of differentiation possible. Also, you can do the case let D as dog and do something because it is a dog. The last thing that I want to note is any object and any should not be abused. For most of the time, we want to specify the data's type as specific as possible because we want to take advantage of the type system. Both any object and any kind of hide the data type from the compiler, which sometimes can be useful, but sometimes can be dangerous. Thank you for watching. Feel free to download the notes from my website and practice with it. See you next time.